The topic of our experiment is open circuit characteristics of the DC compound generator. So the aim of this experiment is to study the open circuit characteristics of a DC compound generator, and the objectives are to plot the open circuit characteristics of long shunt cumulative compound generator and to plot the open circuit characteristics of long shunt differential compound generator. Before going into the experiment, first let us briefly see the theory of this experiment. What is compound generator? The combination of both series and shunt generator is known as the compound generator, and the classifications are: number 1, cumulative compound generator; number 2, differential compound generator. In case of cumulative compound generator, the voltage drop in the armature resistance and the drops due to armature reaction takes place inside the generator. The flux produced is in same direction so that the flux gets added up. And in differential compound generator, the flux produced is in opposite to each other. So this is the circuit diagram of long shunt cumulative generator. This is the supply side, and this is the motor side, and this is the generator side. In our experiment, we make the circuit diagram, circuit connections referring to this circuit diagram. So here in the motor side, the value of R1, that is resistor 1, is kept at minimum so that the high current flows for easily starting torque. And in generator, the value of R2 is kept at its maximum value so that the current can be controlled from minimum to maximum. And this is the diagram, figure diagram of circuit diagram of long shunt differential generator. The only difference between the long shunt cumulative generator and the long shunt differential generator is the positions of the D2 and the D1. In case of cumulative generator, the D1 is here and D2 is here connected in series, and in case of differential generator, the D1 is before the D2 is before the D1, which is also connected in series. And here also the value of R1 value at motor side is kept at minimum, and the R2 value at the generator side is kept at maximum with the same reason as that of in cumulative generator. So these are the procedures of this experiment. Number 1 is to make the circuit connections as per the circuit diagram shown in the figure 1 for the long shunt cumulative compound generator, which I have said. Then verify the circuit connection. This is the most important thing. Before giving the power supply, you need to verify the circuit diagram. Then start the prime mover and adjust the speed of the motor to rated speed, that is 3000 rpm, but in our experiment we have kept it to 2500 rpm throughout our experiment, which you can also do. Then adjust the field of the generator so that the generator reaches the rated voltage, that is 220 volt. Then take the reading of the field current and field voltage for the long shunt differential compound generator. Exchange the terminal D1 and D2 of the series field and repeat the same procedure from step 3. So finally, plot the graph of the field IF versus field voltage VF for the both experiment. These procedures are more detailedly explained in our experiment, which you are going to know in the following.
Now we can trace the connection in the differential compound generator. Here the positive terminal of the source is connected to the A1, whereas A1 and E1 are shorted. And from the A2 of the motor side, it is connected to the negative terminal of the source. And the voltmeter here in our case is connected directly to the source, whereas we have other alternative. We can connect the voltmeter here at A1 and A2. Now to measure the field current and to maintain it at constant or rated current, we have to connect ammeter as well as voltmeter. In case of generator side, we have to short circuit the A1 and D1, whereas D1 is connected to the E1. Then from the E1 we are connecting the ammeter to measure the field current, and from ammeter it is connecting with the rheostat. In case of generator side, we must maintain the rheostat at maximum. And to measure the field voltage, we are connecting voltmeter here, and the positive terminal of the voltmeter is connected to the A2, whereas its negative terminal is connected to the D2. And from the A2, we are connecting it to the rheostat. And we must remember this rated voltage and current at generator as well as in the motor side. Firstly, we have to measure the motor speed. Here, the motor speed given is 2572. The speed here in this experiment must be maintained constant throughout this experiment. After giving supply from the power supply, now we got the residual voltage of 11.33 volts at 0 ammeter. Here is the rated and field current is given 0.19 ampere. We can take the range of 10 milliampere to measure the voltage. Firstly, let's take the range of 10. Here at 10 milliampere we got the voltage of 19.24 at 10 milliampere, and we can proceed with 20, 30 and 40, and now we can let's see at 190 maximum voltage. At maximum current, that is 190 ammeter, we have got a voltage of 210.8. Measure the speed of the generator on. Here the speed given is 2576. It is constant, right? Whereas we also take the speed of 2500 in motor side. Here at 0 ampere we got the voltage of 9.90. It is the residual voltage. Here the given rated current is 190 milliampere. So we must take the range of 10. Here at 10 milliampere we got current of 27.46, and we can proceed on with 20 milliampere, 30 and 40 and so on. Next, let us see the voltage at maximum or rated current. The given rated current of the generator is 190 milliampere. Here at rated current we got the voltmeter of reading 199.2 volts. Here at voltmeter side we got the reading of 199.2.
This is the data that we have recorded from the experiment of long shunt cumulative compound generator. Here, when the field current is 0 milliampere, the field voltage is 11.25 volt, and when the field current is 10 milliampere, the field voltage is 19.32 volt. As the field current increases, the field voltage also increases, and when the field current is 190 milliampere, which is the rated current, the field voltage is 210.8 volt. So this is the graph of our cumulative generator, which is drawn from the data that we have recorded. So the x-axis is field current and the y-axis is the field voltage. Here, as the field current increases, the field voltage also increases. So this is the data for our long shunt differential compound generator. Here, when the field current is 0 milliampere, the field voltage is 9.9 volt. And as the field current increases, the field voltage also increases. When the field current reaches the 190 milliampere, which is the rated current, the field voltage reaches the 199.2 volt. And this is the graph for our differential compound generator, which we have drawn from the data that we have recorded. Here the x-axis is the field current, which is in milliampere, and the y-axis is field voltage, which is in volt. Here also, as the current increases, the voltage also increases. Therefore, we can conclude that the field voltage and field current are directly proportional. Then these are the precautions for our experiment. The precautions number 1 says circuit connections should be tight and right. Make sure that the connections that you have made is tight, so that there is no disconnection, there is continued connections. Then it should be right, so that you will get the right reading, correct reading, and the ammeter and the voltmeter of proper range should be used. If you have to measure the smaller unit of current, then the range of your ammeter should be in milliampere, and similarly it goes with the voltmeter also. Then avoid the parallax error. This you should take care while reading the current or the voltage. Then verify the circuit connections before supplying the power. You must verify your circuit connections before giving the supply with your lab assistant or the tutor. Then this is the conclusions of our experiment. From this experiment, we can conclude that field current, that is IF, and voltage are directly proportional to each other. That is, as the current increases, correspondingly the voltage also increases. It increases because at no load there is no current flow in the series field winding.